What if I told you the most famous moon landing mystery is not just about what happened on the moon, but about why so many people still doubt it? July 1969. Millions of eyes glued to their screens. A tiny spacecraft called Apollo 11 is falling toward the moon, carrying 3 men, Neil Armstrong, Buzz Aldrin, and Michael Collins. For the first time in human history, people were about to step onto another world. And then Armstrong says the words that changed history. That's one small step for man, one giant leap for mankind. But here is where the mystery begins. Even after one of the most heavily documented missions ever, people still ask, was it real? Could NASA have faked it? Why does the flag seem to move? Why are there no stars in the photos? Why does the shadow look strange? These questions sound shocking at first. And that is exactly why this story still spreads so easily. Because mystery spreads faster than truth when truth is complicated. So let us do this properly. Not with blind belief, not with conspiracy noise, but with physics, engineering, and a little common sense. Apollo 11 was not one miracle. It was thousands of tiny, testable miracles. Rocket equations, heat shielding, communication signals, orbital mechanics, fuel calculations. And one extremely important fact, the moon landing was not claimed by one photo or one speech. It was supported by telemetry, tracking data, mission logs, video, radio signals, and later, even lunar surface evidence. But still, the biggest question remains, if it was real, why do some details look so strange? That is where this story gets interesting. Let's start with the most famous evidence people point to, the waving flag. In the footage, the American flag looks like it's fluttering. And instantly, people say, wait, there's no air on the moon, so how can a flag move? Sounds convincing, until you understand the physics. On the moon, there is almost no atmosphere. That means no air resistance. On Earth, when you move a flag, air slows it down quickly. But in a vacuum, once something starts moving, it keeps moving longer. This is basic inertia, Newton's first law of motion. When the astronauts planted the flag, they had to twist it into the ground. That twisting motion transferred energy into the flag. And because there's no air to dampen that motion, it kept oscillating longer than it would on Earth. So instead of stopping quickly, it looked like it was waving. But here's the twist most people miss. The flag actually had a horizontal rod at the top to keep it extended. That's why it looks stretched out even without wind. Without that rod, the flag would just hang down and look lifeless in low gravity. So what looks like wind is actually physics behaving exactly how it should in a vacuum. Now let's move to another mystery, one that feels even more suspicious. The photos from the moon show a pitch black sky with 0 stars. Think about that. No atmosphere, no light pollution. The sky should be full of stars, right? So why don't we see them? This is where human perception and camera science collide. Here's the part most people don't realize. Cameras don't see the world the way our eyes do. On the moon, the surface is extremely bright. Sunlight hits the lunar soil and reflects strongly, almost like a desert under harsh sunlight. The astronauts' suits were also bright white, reflecting a lot of light. To capture this without overexposing the image, NASA had to use very fast shutter speeds and low exposure settings. Now think about stars. Even though they're incredibly bright in space, from that distance they appear very faint compared to the sunlit surface of the moon. With the camera settings adjusted for the bright foreground, the stars simply didn't register on film. It's the same reason you can't see stars in daytime on Earth. And here's something you can test yourself. Take a photo of a brightly lit object at night using a fast shutter speed. The background stars will disappear, not because they're not there, but because your camera isn't sensitive enough in that setting. So the missing stars aren't missing at all. They're just invisible under those exposure conditions. Now let's talk about something even more confusing, the shadows. In some Apollo photos, shadows don't look parallel. Some appear angled in different directions. And this is where many people say, aha, multiple light sources! It must be a studio setup. But this is where perspective plays tricks on your brain. On the moon, the sun is the only major light source.
There are no streetlights, no atmosphere scattering light like on Earth. So logically, all shadows should be parallel, and they actually are. But here's where your brain gets fooled. When parallel lines stretch across uneven terrain and you view them from a specific angle, they can appear to converge or diverge. It's the same illusion you see when standing on a straight road. The sides of the road look like they're meeting at a point in the distance. That's perspective, not reality. Now add another factor. The moon's surface isn't flat. It's filled with small craters, slopes, and bumps. When shadows fall across these uneven surfaces, their angles can look distorted. Some shadows may appear shorter, longer, or tilted differently, even though they're all being cast by the same sun. And there's more. Light doesn't just travel directly. It also reflects. The lunar surface can bounce sunlight into shadowed areas, slightly illuminating them. This is called secondary illumination. It can make shadows look softer or differently shaped, which again creates the illusion of multiple light sources. So what looks like a studio setup is actually a mix of geometry, terrain, and light physics working together. But now let's step into something deeper, something that goes beyond photos and enters the realm of verification. Because even if you doubt images, you still have to answer one question. How do we know, scientifically, that humans actually reached the moon? Here's where the mystery starts to collapse under real, testable science. During the mission, the astronauts didn't just plant a flag and leave. They placed something called a laser-ranging retroreflector on the moon's surface. This device is still there today. And here's the crazy part. Scientists on Earth can fire a laser beam at the moon, and it reflects back. This is not theory. This is something observatories around the world still do. By measuring the time it takes for the laser to return, we can calculate the exact distance between Earth and the moon with centimeter-level accuracy. Think about that. For this to work, something physical must be sitting on the moon, precisely positioned. And yes, multiple missions placed reflectors, not just one. Now ask yourself, if the moon landing was faked, how did these devices get there? And it gets even stronger. The Apollo missions were tracked in real time, not just by NASA, but by independent tracking stations across the globe, including countries that were not exactly friendly with the United States during the Cold War. If this had been staged, rival nations like the Soviet Union had every incentive to expose it, but they didn't. In fact, they confirmed the mission data.
The lunar surface can bounce sunlight into shadowed areas, slightly illuminating them. This is called secondary illumination. It can make shadows look softer or differently shaped, which again creates the illusion of multiple light sources. So what looks like a studio setup is actually a mix of geometry, terrain, and light physics working together. But now let's step into something deeper, something that goes beyond photos and enters the realm of verification. Because even if you doubt images, you still have to answer one question. How do we know, scientifically, that humans actually reached the moon? 5-part moon landing.